Okay, so here we go. We're going to try and figure out what this is telling me to do. This says take 1 over 64, raise it to the negative 4/3 power. So the first thing I see is that negative sign, which tells me to invert the fraction here. So it's going to be 64 over 1 raised to the negative 4. Oh, I'm sorry. Now it's the positive 4/3 power, right? Because once I inverted it, I can make this positive. So what does this mean to do? Well, another way to write this, remember if it's in the denominator, it means take the cube root of 64 and then raise that to the 4th power, right? And 64, I could do it to 1, but we could just rewrite this as 64, right, to the 4/3, right? Because the one you can cube it, take the cube root of it, and then, take to the 4th power, and it's still going to be 1. So that's the same thing here, right? 64 to the 4/3 is equal to 64 to the cube root of 64 raised to the 4th power. And I'm going to choose to look at it like this because I could write this as, another way to write this, and it's kind of ugly here, I think, cube root of 64 to the 4th. Now this, for me, and for a lot of people, might be a little bit harder to think about this, right? And that is because here I am, you're going to have to multiply 64 times itself 4 times and then find the cube root of it. It turns out that 64, the cube root, and if you get around enough to where you're doing, math regularly and finding cube roots, you might recognize that 64 is what we call a perfect cube, and that's because it's 4 times 4 times 4. So 4 times 4 is 16 times 4 is 64. So the cube root of 64 is equal to 4. And if I raise that to the 4th power, well, that'd be 4 times 4 times 4. That's 3. That'd turn it back into 64. And then times 4 one more time, which is going to be 256. So that's my answer. And I know these. I've used these numbers so many times. But I wouldn't want you to try to do these in your head. In fact, I shouldn't even be doing them in my head. Let me just do them using my calculator. So the easiest way to look at this is to begin with 1 over 64. And then we're going to raise that to the negative 4/3 power, and we got 256. And how does that work? Well, that's the same thing as saying 64, I don't even need to do this. I just go 64. I don't need a fraction bar. I don't need a parentheses anymore because I'm just raising this base to the power. 64 raised to the 4/3 power, which is the same thing, right? This is the same thing as saying 64 to the 4th power, and then take the nth root of that. So let's try doing that and take the 3rd root of that. That's the same thing. It's all the same here. We still get 256. I could also say, let's take the, let's take this. Take the cube root, this is what I did, right? Take the cube root of 64 and then raise that to the 4th power, right? And let's see what that looks like. Because if I just took the cube root of 64, that was 4. So then I raise it to the 4th power, that's when I get 256. A lot of ways to write this and think about this, okay? Which is what I'm basically doing here. But recognize the first thing we did was we inverted the fraction, right? Because that made that exponent positive. And really what we did was we brought that and we applied the negative 4/3 power here, and then to make this positive, we move this into the numerator and we apply the negative 4/3 there, and to make it positive, we move it into the denominator. So, that's really what we're doing here is we're inverting it and making the powers positive. And then looking at it a number of different ways. Here I like to think of this as the cube root of 64, which is 4. And I know that number. And then 4 to the 4th. But it doesn't really matter how you do it. Our answer is going to be the same. It's 256. So let's put that in there. 256. And let's check another problem like this, okay? 27 over 125. Well, this is the cube root of 27 is 3. The cube root of 125 is 5. Those I just happen to know. So, but let's just put it in. 27 divided by 125, and then raise that to the negative 4/3 power. All right, isn't that what I had? 27 over 125 raised to the negative 4/3 power. Now we are inverting this fraction, finding the cube root of each, so that would be 5/3, and then taken to the 4th power. So 5 times 5 times 5 times 5, which was 625, and 3 times 3 times 3 times 3, which was 81. So I should have 625 over 81, and I do. So 625 over 81. So if you're using your CAS system, you should fly through these, because I'm taking my time, I'm explaining them to you. And if not, if you want to do these by hand, you certainly can. But, you know, I really don't know when in your life you would ever really want to do these by hand. And guess what? You don't really even, for these actual numbers, these can be done in the, you don't need to have this as a, let's see, 3/2 power. You don't need to have a CAS calculator. You can do this with any calculator that allows you to do, you know, nth roots and raise things to a power. I could just put it in. If I had the blue calculator, I could use that as well. So that's just how I would do these. 216 divided by 343. And you should fly through these, right? 4 to the 3/2 power to the 3/2 power. And just put your answers in. And 1/125th, and that is to the negative 2/3 power. That's 25. Okay, that's how you do fractional exponents too.